ready? Is it on? All right. Hello, Brandon. Hope you're okay, and maybe even get in a few minutes. But for now, we're videotaping this for you. So let's look up here at the golden vector. So put away all your other papers.
Golden vector.
The golden vector. We're on day 3. The golden, you won't write this on day 3, but the only thing you need out is day 3. And put everything else out of your sight, except for day 3. And look up here at the golden vector. La! The golden vector has some secrets that has been whispering to us actually down through the ages. This was discovered in BC, and we're still studying it, so it's here to stay. So the golden vector said that if you knew the components, say that this component, the x component of this vector, say it was 2. And this vector, say it was 3, like that. We can go from components to what we call magnitude and angle. So have your calculators out to help me with the golden vector. And tell me what is just to 2 decimal places, what is this hypotenuse? Because that's called the magnitude, and you'll have to Pythag it. And I need 2 decimals. Anybody?
3.6.
3.6 confirmed. Anyone else get 3.6? Yeah. All right. I said decimals, but I meant digits. That's fine. 3.6. And then, what was the tool that we bring out to find this angle here? Alex, you recall, after we Pythagged it, what did we use to get the angle?
We, square root.
No, I already did that. That's part of Pythagorean.
Tan.
What is it?
Tan -1.
Right, inverse tan. So the inverse tan, if you would. Alex, which one goes on the top when you inverse tan? Is it 3 over 2 or 2 over 3?
3 over 2.
It is side opposite the angle divided by the side next to, adjacent to. So inverse tan 3 over 2, and give me the angle. Anyone? 56. Thank you. All right. So that's what we've been doing pages of those. So I think we should have that down by now. So you recall, Pythag it, inverse tan. Oops, I forgot the last step. The last step is to adjust. We have to adjust. This actual golden vector is in the first quadrant, so there is no adjustment. But we have this. All right. So let's review that. When I point to you, you say Pythag. When I point to you, you say inverse tan. And when I point to you guys, you say adjust.
Adjust.
Inverse tan.
Adjust.
Tag.
Fag.
They get to say Pythag.
Right,
Not you.
Fag.
Inverse tan.
Adjust.
All right, now you guys say Pythag, but you guys say it like high, like inverse tan. And you say adjust. You can say it lower than me. All right.
Spanish whispering.
Fag.
Inverse tan.
Adjust.
Adjust. Right, adjust. All right, we got to get it right.
Fag.
Inverse tan.
Oh.
I knew. I made sure he was on that team. All right, Pythag inverse tan and adjust. All right, goodbye. We're going on to day 3. That was day 2. So golden vector has more to teach us. So let's see what we do this
So that
time.
was the golden lesson of the golden vector from the
That
golden
was
ages?
What was that?
Is that the golden lesson of the golden vector from the golden ages?
Yes, it is.
Alright.
Related to the golden ratio. Not really. All right, so let's go look at this vector from another perspective. And today, instead of giving you the x and y component, I'm going to give you the magnitude and the angle. So let's take a note on our day 3 work. And I'm going to call this golden vector G. So draw a vector on your day 3 notes and call it G. We'll just have it sitting there like that. And let's say that the golden vector is 5 long. So the length of the vector is 5, and the angle is say 30 degrees. So draw that on your day 3 notes. And this will be the first problem where we're going to go the other way.
Do we have a measurement
Of,
for 5?
what do you mean?
Like
Oh,
unit?
yeah, we should make something up. 5 meters, thank you. The unit is what you were
Yep.
referring to, thank you. All right, so now I'm going to ask you to come up with the x and the y components. So I want
Oh, Y is the
gx
measurement.
and gy, like that. In order to do that, we have to pull out our trig functions. So remembering sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this one, he spent way too much time on day 2, so we're going to retire him, but we're going to look at sine and cosine. So do you see that I can say the sine of the angle, in this case, opposite over hypotenuse, the angle is known. So I don't write sine of theta, I write sine of 30. Side opposite is gy, the y component, divided by the hypotenuse, which is known, 5. So how do I solve this for the g component? So I want this all by itself. So mathematically, Emily, what will I do?
Multiply by 5.
All right, multiply both sides by 5. So make sure you're in degrees and take sine 30 and multiply by 5. Emily, number 2. I'm trying not to say last names on the video. It's hard with you guys. So,
It's 2.5.
what is it?
2.5.
2.5 confirmed?
Yes.
All right, so go back to your golden vector and put a 2.5 meters next to that. What trig function do you suppose, Zach, are we going to use to find the x component?
You can just use the oh my gosh, yeah, the hypotenuse, c squared plus equals a squared plus b squared.
Oh, you could do the Pythagorean theorem, you're right. But let's use trig instead, because one thing, this was calculated. So what if it's wrong? So let's stick with, we know this for sure, and we know this for sure because it was given. So let's use a trig function instead of the Pythagorean theorem to come up with gx. So which trig function? We just use this one?
So cosine
All right, so what would it be? Cosine of 30 equals what?
adjacent over hypotenuse.
And in this case?
Gx over 5.
Right. All right, so once again, you're going to multiply both sides by 5, and you're going to get the fact that 5 cosine 30 is what? Can you get that for me, Emily, number 3?
4.3.
All right. And we'll put that on our picture in meters as well. All right, so sine and cosine are the functions of the hour. Do you need to see another one, or can we just practice some of those? Let's do one more. All right, try this one. Let's do one in another quadrant. So we're going to spin the golden vector. Make sure you have the answers written on the golden vector, or on your vector. All right. We'll do another one, maybe we'll do 2. Let's spin the golden vector. So I'm going to put it down here. All right, the golden vector is now pointing, so if this was on a coordinate plane, it would be in the 4th quadrant. So make sure your golden vector is in the 4th quadrant. Let's say it has a length of 6, and we are looking for the x component and the y component. So we're expecting the x component to have one. Is it going to be positive or negative, and the y component to be positive or negative? We have some expectations here. So, Alex, what do you expect the x component to be, a positive value or a negative value?
Probably positive.
It is, because it went to the right.
Right, and then
And
a
then-
squared, b squared equals c squared, and then
And what
It
about
couldn't be
down
negative.
here?
Hmm?
What, do you expect the y to be negative or positive?
positive.
No, because it went down.
Oh, so yeah.
Alright, so the x went to the right, that's positive direction in
the
x,
negatives
and
went
the
down.
y went down.
Makes
So
sense.
we are expecting a positive x and a negative y. The angle is, from here to here, is 300 degrees, so draw that in. And the command is find the x and y component. Alright, see if you can work a second ahead of me. It's going to be done the same. We don't need our inverse tan map. So I'll get rid of that so it's not cluttering our thoughts. Alright, if you're stuck, you can watch me. I'm going to look out for the y first. So sine of the angle is opposite over hypotenuse. So 6 sine of 300 equals y. And then, without even looking, setting it up, I know 6 cosine of 300 is x. These get very quick when you recognize the pattern. It's always the length of the golden angle, or golden vector, times the sine of the angle for y, and the length of the golden vector times the cosine of the angle for x, over and over and over. So, Hunter, do you have any of those values? 6 sine of 300, would you get one or the other?
Y is negative 5 point, how many decimal points? are
Just
there?
one.
Oh, then it'd be 5.2.
Alright, so that's my y component. So I'm going to put it over here, and let's say we're in feet this time. So I'll give it negative 5.2 feet. Draw it right on your picture once you have it. And Hunter, what's the other one? 6 cosine 300.
3.
3 even.
Yeah.
Alright, I'll say 3.0 for x. Emily, 2, number 2.
Could you also do like sine 60?
Yes, but you will not get the negative that's
Yeah.
desired, and you'd have to know to put it in.
Okay.
So you
it's
have
just
that
like
option as
300.
well. Alright, I had to teach it one way or the other, so
Okay,
I
that's
went this way.
That's fine.
Okay. Alright, let's see if you can do some of these. On the back of day 3, if you turn it over, I would like to do number 1 together and show you what I expect on each spot. So, number 1 is given, and the command is find the x and y components, include a sketch. So number 1, start with your sketch. So it's going to be at 110. So what quadrant, Brian, will 110 end up in? Uh-huh.
Oh, sorry, the second quadrant.
Right, so we have 0, 90, 180, and 270 as guideposts. So 110 is somewhere right in here. And you don't have to have it at the exact relative spot for 110, but it has to be in the correct quadrant, and then remember this is just marked as 110. So in your sketch, make sure it's clear. We're on the back of this, Alex.
Oh, it's bad.
Alright, so
That's so like.
we're doing number 1 together, and we've drawn in the angle 110, and we're going to mark the hypotenuse as 7 meters. Alright, make the triangle that you need for your trig by always connecting the head of the arrow with the x-axis. Could you go over to the y-axis? You can, but then you'd have to use totally different angles in trig functions. And you can figure that out if you'd like to do that. But this is how I taught it, and it works. And if we all do it the same way, it's easier to grade, but you may go ahead and use the y-axis and figure it out for yourself. Alright, so let me make this clear that this is 7. Alright, this is 7 and 110. So go ahead and see if you can find the x, mark x and y and find those values. Remember, it's sine for y and cosine for x.